Hi there. In this lesson, we're going to be looking at what's called factoring by grouping. And really, this is a process for factoring polynomials. We're going to take our basic rules for factoring, and we're going to kind of apply them multiple times in order to factor a polynomial completely. All right? The first thing we're going to do is we're going to take the polynomial, we're going to split it into groups, okay? I'm going to group the terms using parentheses. And typically for that, we're going to put them in groups of two. That's almost always going to be the case for our purposes, although there are certain situations where groups of more than two can be useful. The second thing we're going to do is we're going to factor out the greatest common factor out of each of those groups. Okay, so we put them in groups of two, and then we factor the greatest common factor out of each group. And then the last thing we do is we look for common polynomials that are common throughout this thing. So we're looking for entire terms, either a binomial or trinomial, or something like that, that we see repeated more than once. Okay, so we put them in groups using parentheses, we factor the greatest common factor out of each group, and then we look for common polynomials that we can factor out. Okay? For example, if I look at something like this guy, I've got 4 terms here, and I'm going to group them. I'm going to put them in groups of 2 using parentheses. So I'm going to put these first 2 together with a set of parentheses, and then I'm going to put the second 2 together with a set of parentheses. And notice that when I draw those parentheses, I include the plus sign here because I want to remind myself that that's a positive 2. And so those signs in front of those terms are very important. So include the sign inside your parentheses. When I look at that first group, if I were to ignore this second group for a second, if I were to kind of scribble that out and just look at that first group, if I had a 3n cubed minus a 12n squared, the greatest common factor here would be a 3n squared. That's the largest thing I can divide evenly out of each. And if I were to divide that out, the 3n cubed divided by the 3n squared leaves me with an n. The 12n squared divided by the 3n squared, this is going to be a minus 4, and that's it. So what I've done is factored out the greatest common factor out of this group. Now I'm going to do the same thing with the second group. So this time, if I put my parentheses back in place here, this time I'm going to ignore the first group and just look at the second group here. So if I were to ignore this guy for a moment and just looked at the 2n minus 8, the greatest common factor here is a 2. It's a positive 2, so I'm going to write a plus 2 down. And if I were to factor that out, I divide out the 2. It leaves me with an n and a minus 4. Okay? So now looking at this thing as I look across, now I'm going to look for common polynomials. I've already done the first 2 steps. I put them in groups. I factored the greatest common factor out of each group. Now I look and I see this n plus 4 repeats. So I have an entire binomial that's listed twice here. And what I'm going to do is I'm going to factor out that binomial. So I take the n minus 4 and I factor it out of here. So if I look at this thing, this whole piece as one term, and I look at this whole piece as another term, I'm basically going to take out this piece right here. If I were to take this away, it leaves me with just the 3n squared. And it's the same thing here. If I were to take this piece away, factor it out, it leaves me with just the plus 2. So my other factor that I have here is the 3n squared plus 2. Okay? So what I've done is I've taken that polynomial, I've set it off to the side, and then by covering it up, by getting rid of that polynomial from each of those groups, I can see that I'm left with the 3n squared plus 2. That's factoring by grouping. That's how it works. Okay? Let me redraw this thing just so it looks really nice for us. But again, we factored out that greatest common factor, the 3n squared, which left me with the n minus 4. We factored out the plus 2, which left me with the n minus 4. So now I've taken this n minus 4, I've rewritten it in one location, and that would leave me with the 3n squared plus 2. Okay? And again, I could write this as any order. It's multiplication, so I could write the 3n squared plus 2 first, and then the n minus 4. Either one of these would be acceptable as an answer. Okay? If I look at the next one, again, I'm going to put these into groups of 2. So I group the first 2 together. I group the second 2 together. Out of the first group, if I look at the 4x squared minus the 8x cubed, I can factor out a 4, and I can also factor out an x cubed. And if I were to divide that out, it leaves me with an x and a minus 2. Out of the second group, the 12x squared minus the 24x, I can factor out a positive 12x. And if I were to divide that out, it leaves me with an x and a minus 2. So now I see once again that I have a common polynomial here. So I write that common polynomial in one location. And if I were to write that common polynomial, the x minus 2 here, it leaves me up here with the 4x cubed and a plus 12x squared. So that's my other factor here. But now there's a little bit of an issue with this one. If I look at that second factor that I've written, the 4x cubed plus the 12x, that's not factored completely because that still has a greatest common factor left in it. If I look here between the 4 and the 12, they have a 4 in common. Between the x cubed and the x, they have an x in common. In other words, I can factor out a 4x out of that entire second polynomial. And if I were to factor out that 4x, if I were to divide it out, it leaves me with an x and a plus 3. Okay? And this first polynomial that I had, the x minus 2, that remains unaffected by this. So I'm just going to bring that guy along for the ride. And again, the order in which these are written doesn't matter, but I have to have that 4x pulled out. And it leads me back to an interesting scenario here as I look back at the original problem. If you look back at the original problem before I grouped this, you should notice that every single one of these has a 4 and an x in common. So when you approach these problems, either double check your final results here or try to factor out the greatest common factor first. If in this one I factor out the greatest common factor first, if I find that 4x right away, that's going to leave me with an x cubed minus 2x squared plus 3x and a minus 6. And now I'm going to look at that polynomial that's inside the parentheses, and I'm going to group them. I group the first two terms together. I group the second two terms together. The 4x is just going to kind of tag along for the ride here. But out of those first two terms, I can factor out an x squared, which leaves me with an x and a minus 2. Out of the second two terms, I can factor out a plus 3, which leaves me with an x and a minus 2. Again, this 4x kind of tags along for the ride. I rewrite the x minus 2, that common polynomial, in one location, x minus 2. And if I were to take that x minus 2 away, I can see that it leaves me with an x squared and a plus 3. And if we look, this is exactly what I had in the previous example. Okay? Although I missed my squared in the previous one, so there it is. Okay? I get the same thing. It's easier typically if we factor out the greatest common factor first. Okay? Less room for error there. All right? If I look at the next one, here, again, I'm going to put them in groups. But before I do that, let's look for a greatest common factor. If I look across at each of these, it looks like every single one of them has at least an x in common. So I'm going to factor out that x first, which is going to leave me with a 3x cubed plus a 9x squared minus x minus 3. And now I'm going to do my factoring by grouping. I'll group the first two together. I'll group the second two together. Right? The x just kind of tags along for the ride. Out of this first group, the 3x cubed and the 9x squared, I can factor out a 3x squared. When I divide that out, it leaves me with an x plus 3. Out of the second group, when I look at this, there's not really much I can factor out here, and maybe you can't see anything. With factoring by grouping, we have to factor something out. So in this case, we have to factor out a form of 1. And if I factor out a positive 1, it leaves me with a negative x minus 3, which, if we look, that doesn't help us because this is an x plus 3 and this is a negative x minus 3, which isn't the same thing. All right? So instead, what I'm going to do is I'm going to try factoring out a negative 1. And if I factor out a negative 1 instead, that leaves me with a positive x and a plus 3. So sometimes we have to play with the signs of these things that we factor out. Typically, if my first term in that second group has a negative in front of it, I'm going to factor out a negative. Now we can see that we have this common polynomial of the x plus 3. So I'm going to write that in a single location. Again, this x tags along for the ride. The x plus 3 gets written right here in a single location. And then when I take that x plus 3 away, I'm left with a 3x squared and a minus 1. Okay? That's factoring by grouping.